In this video, we are going to study about atoms and molecules. The first scientific theory of atom was proposed by John Dalton. He proposed few postulates which were later on found incorrect by J.J. Thomson, Schrödinger, Rutherford, Niels Bohr, and so on. Later on, a new theory known as modern atomic theory was put forward. There are 7 postulates in modern atomic theory and they are as follows. The first postulate says an atom is no longer indivisible, meaning an atom is divisible. That is, an atom can be divided into subatomic particles like electrons, protons, neutrons, etc. The second postulate says atoms of the same element may have different atomic mass. To understand this concept, you must know about atomic number, atomic mass, and isotopes. Atomic number is the number of electrons or the number of protons present in an atom. Always, the number of electrons will be equal to the number of protons. Atomic mass is the sum of the number of protons and neutrons present in the nucleus of the atom. Isotopes are atoms of the same element having same atomic number but different mass number. For example, chlorine has 2 isotopes, they are chlorine 35 and chlorine 37. Whereas hydrogen has 3 isotopes with a mass number 1, 2 and 3. Protium, deuterium and tritium. It means atoms of same element should have same atomic number and mass number. But some atoms of the same element may have different mass number due to the difference in the number of neutrons. When you consider chlorine has 2 isotopes, one is chlorine 35 and the other is chlorine 37. When you compare the number of electrons, protons and neutrons present in both the isotopes, the number of electrons and protons remain the same, that is 17 each. But when you come to the number of neutrons, chlorine 35 possesses 18 neutrons and chlorine 37 possesses 20 neutrons. So hence the difference is in the number of neutrons present in the nucleus of the atom. So due to this variation in the number of neutrons, there are some atoms of the same element having different mass number or different atomic mass, thus forming isotopes. The third postulate is atoms of different elements may have same atomic masses. This is due to the existence of isobars, where isobars are atoms of different elements having same atomic masses. For example, argon with atomic number 18 and calcium with atomic number 20 have same atomic mass, that is 40. The fourth postulate is atoms of one element can be transmuted into atoms of other element by artificial transmutation, meaning atoms are destructible. That is, atom of one element can be converted into atom of another element. According to the fifth postulate, atoms may not combine in a simple whole number ratio. Example, glucose with a molecular formula C6H12O6. The carbon, hydrogen and oxygen combine in a ratio 6:12:6, which on simplifying becomes 1:2:1. Thus a simple whole number ratio is obtained. But in the case of sucrose with the molecular formula C12H22O11, the carbon, hydrogen and oxygen combine in a ratio 12:22:11. This ratio cannot be simplified further. So, there is no simple whole number ratio. The meaning of this postulate is the ratio in which the atoms combine to form a compound need not always be a simple whole number ratio. The sixth postulate states that atom is the smallest particle which takes part in a chemical reaction. For this, let us consider a chemical equation. Sodium hydroxide plus hydrochloric acid gives sodium chloride and water. In this reaction, we can see the combination of atoms. One atom of sodium combines with one atom of chlorine to form sodium chloride. One atom of oxygen and two atoms of hydrogen combine to form water. Hence, atoms of the reactants combine in different ways to form the product. The seventh postulate is mass of an atom can be converted into energy. This was proved by Einstein's mass energy relation E is equal to mc square, where m is the mass of the substance taken and c is the velocity of light. For example, the conversion of radioactive substance into atomic energy or nuclear energy in the case of atomic power station and nuclear reactors. We will study about this in detail in nuclear physics.